Okay, so equations are important, and that is absolutely true. Just like we did with the distribute lots assignment, we're just going to repeat until these become just second nature to you. All right, so when we say to solve an equation, we mean find all possible values that we could substitute in for the variable and make the statement true. Okay, so our method involves usually 5 steps. Okay, we first look to see is there any, we try to simplify, but that can mean 2 things. That can mean distribute if there are parentheses, and the second step of simplifying is combining like terms, and when I say that I mean on the same side. All right, so both of these steps are really simplifying. Then if there are variables on both sides, we want to move all variables to one side. Then we get rid of any adding or subtracting, and the last thing we do is get rid of any multiplication or division. Those steps do need to be altered slightly when we get to an equation where there is a big complex fraction. And I think that happens about number 5 on this assignment, so I'll talk about that when we get there. So number 1, if we go through these steps, is there anything to distribute? Well, since there are no parentheses, there's nothing to distribute. That step is done. We look for like terms that are already on the same side. We don't have any of those either. I'm not referring to 9x and 12x or negative 14 and negative 41 because they're on separate sides of the equal sign. So step 2, there's nothing to do. Step 3, we want to get all of our variables onto one side. So here we do have 9x on the left and 12x on the right. Now it does not matter which side you put the variables. It does not matter which one you cancel. Usually what most people try to do, and that's for the sake of keeping the x's positive, is they try to cancel the smaller amount of your variable. So for example, this is 9x, this right side is 12x, 9x is smaller. So that's the one I want to cancel. Okay? So to get rid of that term, to remove it completely from the left, it's positive as it is now, I need to subtract 9x. Subtract 9x on the right. Well, 9x minus 9x is gone, it's canceled. The only thing left over here on this side is negative 14. That's equal to 12x minus 9x is 3x, and I still have a minus 41. Okay. The fourth step is to get rid of any adding or subtracting, meaning, remember, I'm trying to isolate this variable, this x, and have it alone when I'm all done on one side. So the thing that's in my way is there's a subtraction by 41 here. Well, the inverse of subtracting 41 would be to add 41. If I do it on the right, I have to also do it on the left. So negative 41 plus 41 is gone, that's 0. Negative 14 plus 41 is 27. And the only thing remaining on the right is 3x. So I've taken care of that. And lastly, get rid of anything multiplication or division. So right now my x is being multiplied by 3. So to cancel that, I need to divide by 3. 3 divided by 3 is 1, so I have 1x, that's just what I wanted, and 27 divided by 3 is 9. Now, I'm not going to go through this with everyone, and you don't have to either, but you can always check your solution to a linear equation. So if you were taking an assessment, if there was something you absolutely had to get right, what you do to check this answer is go back to the original problem. So 9x minus 14 equals 12x minus 41. And substitute that 9 in for x. So replace the x with a 9 everywhere you see an x. So 9, and for that x I'm going to put a 9, minus 14. We're supposed to get that that is equal to 12 times 9 minus 41. Well, 9 times 9 is 81. minus 14. And 81 minus 14 is 67. So is that equal to 12 times 9 minus 41? 12 times 9 is 108, and then minus 41. And 108 minus 41 is also 67. So it's not really, the 67 is not really relevant to us, except for the fact that it is the same number on both sides of the equation. So this is a true statement. 67 does equal 67, and that verifies that 9 is our correct solution. Okay, number 2, again, we're going to go through those 5 steps as a checklist. So do we have anything to distribute? Since there are parentheses here, we do. Negative 4 times 2x and negative 4 times 3. So negative 8x minus 12 is equal to 2x minus 5. Do I have any like terms that are already on the same side? Not on the left and not on the right either. Third step, get all your variables onto one side. Well, I do have x's on both sides of the equation, so I will have to remove one of those. Negative 8 is a smaller amount than 2, so I will cancel the negative 8x by adding 8x. That leaves me with negative 12. Don't lose this sign. Negative 12 is equal to 2x and 8x, 10x, minus 5. Add 5 to both sides to get rid of your subtraction. Negative 12 plus 5 is negative 7. That is equal to 10x. To get rid of multiplication by 10, you divide by 10. So x is equal to negative 7/10. I like that answer. Or that one is a terminating decimal. If you want to say negative 0.7, you are welcome to. Number 3, first thing we look for is distributive property. We do have parentheses, so we are going to distribute. Now, it's not the 17 that gets distributed because that's not right up against your parentheses. It's the negative sign. So negative 4x. If you need to, you can write in a 1 here and think of that as negative 1. So negative 1 times 4x is negative 4x. And negative 1 times negative 1 is positive 1. So if you look at what started out in the parentheses, 4x minus 1, and what we ended up with beneath here, what that negative sign in front of the parentheses did is simply change the signs of everything in the parentheses. It turned positive 4x to negative. It turned negative 1 to positive. Okay. Everything else in the problem stays as it was. Okay. Second step, we look for like terms that are already on the same side. We do have that here. The 17 and the positive 1 are like terms on this left-hand side. So 17 plus 1 is 18. I still have a minus 4x is equal to x minus 2. I need to get all of my variables onto one side. So I ask, which is smaller, negative 4x or positive 1x? The answer to that would be negative 4x is smaller. So to cancel negative 4x, I'll add 4x to both sides, leaving me with 18 equal to 5x minus 2. Is there any adding or subtracting to get rid of? Yes, there's a subtracting 2 here, so we're going to add 2. 18 plus 2 is 20. On the right-hand side, I have just the 5x remaining. And lastly, to get rid of any multiplication or division, since this is being multiplied by 5, I will divide by 5. So x is equal to 4. All right, number 4, there are fractions, 2 of them in here. You must keep them as fractions. Do not try to change 4 over 3 to 1.3. Do not try to change negative 2/3 to 0.6 or 0.7. Okay? Those are rounded. They are not the same as the actual value. So keep rational numbers as fractions. Is there anything to distribute? Yes, on the right-hand side, I need to distribute that negative 2/3. So I'll leave this side alone, 4/3 x plus 8. And as I distribute, negative 2/3 times x is negative 2/3 x. Now, negative 2/3 times negative 12, negative times negative is positive, and 2/3 of 12 is 8. Do we have any like terms already on a side together? No, we do not. Third step, remove one of these variables so that we only have variables on one side. The negative 2/3 x is a smaller amount, so to remove that, to cancel that, it's negative. I'm going to add 2/3 x. Do it on both sides. So 4/3 x plus 2/3 x is 6/3 x. 6/3 is really just 2. So there your fractions went away anyhow. We still have plus 8 is equal to 8. Remove any adding or subtracting. So get rid of this plus 8 by subtracting it. So we have 2x equals 0. And then lastly, remove any multiplication or division. Since this is multiplying by 2, we will divide by 2. X is equal to, now 0 divided by 2 is 0. That's not a problem. Don't worry about getting a solution of 0. That doesn't mean there isn't an answer. It means the only way to make this equation true is to substitute 0 in for both x's. Okay, so number 5 here is what I was referring to earlier as like a complex fraction. When you have 2 or more terms in the numerator of a fraction, then we have to slightly change that 5-step checklist that I gave to you. And instead, what you'll try to do is make sure you have isolated that, again, what I'm calling a complex fraction. Get that to be all alone on one side, and then we'll get rid of the denominator. So in this problem, the 4x plus 9 over 2 is already alone on the left-hand side. So in order to get rid of the fraction part, since it is dividing by 2, we will just multiply both sides by 2. That cancels the denominator, so I'm left with just the numerator, 4x plus 9 equals 32, and then I can jump right back into my checklist. I would say I don't have anything to distribute, I don't have any like terms, and I don't have any variables on both sides. So I'm already now to step 4 from my original checklist, and I would say get rid of any addition or subtraction. To cancel the plus 9, I would do minus 9. So 4x is equal to 23. Divide both sides by 4. X is equal to, now I like the answer 23 over 4, but if you divided that on your calculator, it is a terminating decimal. It's 5 and 75 hundredths, so you're welcome to use that answer also. We have another one like that at number 6, and we'll get to do a little bit more here. If you were unsure what I was saying at the last problem, we first need to isolate this big fraction, meaning anything else on that side, we got to move it. So that plus 5 then is in our way. So how do I get rid of a plus 5? I subtract 5 on both sides. So now I have just this big complex fraction, and on the right-hand side, it's now 6. To cancel the fraction, to get rid of this denominator, it's now dividing by -3. We're going to multiply by -3. Cancels the denominator on the left, leaving me with 6 times 3 minus x, right, equals -18. Again, go back to your checklist. Is there anything to distribute? Yes. 6 times 3 is 18. 6 times -x, -6x. There are no like terms on either side, and there's variables only in one side, so I'm ready to remove any addition or subtraction here. Now, please be careful. This 18 that you're going to try to remove is positive. The negative only goes with the 6x. So it has nothing to do with this 18. To cancel a positive 18, I subtract it. Subtract 18. So negative 6x is equal to a negative 18 and another negative 18 is negative 36. And lastly, to remove that multiplication by negative 6, we divide by negative 6. So x is equal to 6. All right, back to some more standard looking equations, none of those weird fractions. So we need to distribute here on both sides. So distributing the negative 5, I get negative 10x plus 5 equal to negative 10x plus 5. Now, if that already feels a little weird, you're right to think that. As soon as you notice this happening, you'll be able to stop in the future. So what am I talking about? Both sides now, after simplifying, look identical. Now I'm going to keep going so you know exactly what this results in, but if at any other time in the future, as soon as you realize that the two sides are identical, you'll be able to stop and give your answer, okay? So let me go through my steps. I don't have any like terms on either side. I do have variables on both sides, so I need to remove one of those. When I get to that question where I say, well, which one's smaller, negative 10 or negative 10, you can tell, again, why this is a little bit weird. Cancel whichever one you want. So I'm going to say I'm canceling this one. I add 10x to both sides. It cancels all the x's in the problem. I'm left with just 5 equal to 5. Again, the two sides are identical. If you weren't sure, couldn't remember what that meant, and you kept going, well, let me cancel positive 5. I subtract 5 on both sides. So 0 is equal to 0. Again, both sides are identical. I could see that at each step after the first one. 3 different steps there, I could see that the sides were identical. Okay? Now, whenever that's happening, ask yourself, well, what value of x would make 5 equal 5? And the answer to that is, it doesn't matter what x is. Every x you could imagine, any number you could think of to substitute in there for x would work. So this actually has infinitely many solutions. Okay? Every number you've ever heard of would work. So another way to write that is this symbol, this scripty R, which stands for all real numbers. All right, the real numbers are every number on a number line, and all of them work. Again, that is your solution. Every time your variables cancel and you're left with just a constant that equals itself. Okay, let's try number 8, last one. We do have parentheses, so we're going to have to distribute here 3x and minus 15. I still have a 4x in front. Now, since that 3x was positive, I'm writing a plus sign here. It's not necessarily bringing the one down from above. It's because positive 3 times positive x is positive 3x. 12x plus 10 minus 5x. Now I look for any like terms that are already paired up on a side. Well, I have 4x and 3x here makes 7x minus 15. And on this side, I have 12x minus 5x, which is 7x plus 10. Now, this one might start to feel a little suspicious too, since we see we have the same amount of x's on both sides. So like we did previously, just decide you're going to cancel one of them, and it actually cancels both. So you have no more variables left in your problem. It's different from the last question, though, because what I am left with is negative 15 equals 10. Well, that's not true. Whereas the last question, we had 5 equals 5, or 0 equals 0. And we said, well, those are always true statements. Negative 15 doesn't ever equal 10. it doesn't matter what I might substitute for x, there's no way for me to make negative 15 equal to 10. It's just a false statement. So every time this happens, you're going to say there is no solution. And again, in mathematics, we like abbreviations, symbols, so you can abbreviate that with just a circle with a slash through it. All right. So these last two questions, they were similar in that the variables completely canceled out. We were left with no variables in the problem at all. So what you're left with is just constants, and they are either actually truly equal to each other, like number 7, all real numbers work, or it's a flat out lie. Negative 15 equals 10 is a lie, and therefore there's no solution.